Sorry I missed you guys today, but here's the lesson for today. We're on page 609 in activity 1. We're just going to do a brief overview of what it is to do transformations. We've done it before, but it's been a little while. So as a reminder, this is a really good reminder here. So remember the one inside the parentheses with the X, that has to do with the left and right. And so this is shifting left and right. So we're taking the basic graph and we're just going to shift it. We're not, like making it longer or stretching it or anything like that. And so remember, if it's inside the parentheses ends with the X, it's opposite of what you see, because normally, remember, it's supposed to be a minus. So if that C is a positive, that means it's actually going right. So, so again, for me, I always think of it as opposite of what I'm seeing. So this is going to be, if it's negative, then you're shifting right. And if it's positive, or I should say, if you see the plus there, remember the C was a negative number, so it's a minus a negative, which makes it a positive. Yeah, so that's going to shift left. And then this D out here, so the one on the outside, what this does is, if you remember, this shifts it up and down. So we've done this with parabolas, we've done this with a little bit on rational functions, not too much, and not too much in radicals, but we've definitely done it with parabolas and things like that. Anyways, so here it shifts it up and down, as you can see. Shift up and down. So for down, well, up is exactly what we would think it to be. If it's a plus number like +5, then we would shift the whole graph up 5. If it's like a -2, then we would shift it down 2. Do you see what I'm saying? So this is exactly the way we would think it is, because if you notice right here, that's already a plus. So that's the way it is. We're just going to do a couple of these. We're not going to do too many of them. And then I'm going to give you some practice. So this is true for any function that you see, right? So in our case of exponentials, same thing. So what you see drawn here already is the parent function of 2 to the x power. If you notice here is 2 to the x power, but what did we do? We're subtracting 4 from the x. So if you notice, this is 4 from the x. So that's this part right here. It's connected with the x, so we are actually minus, so it's going to be shifting right. So let me see if I can get that color. So what I'm going to do is I'm going to take the whole, do you see where it intersects right here at the y-intercept is right here at 0, 1. So we're going to shift it right 4. So that whole y-axis, we're going to shift it to the right 4. So this is our new y-axis. This is how I like to think of it. So I'm going to be like, new y-axis. I don't normally, label these, but since this is for a video, we're going to just label that. So that's the new y-axis, which means we're going to shift this whole thing to the right 4, every single point to the right 4. So this point, let's see if I could do, so this point right here, that y-intercept is now going to shift to the right 4. So it's now over here. And another nice point that I see, so 2 to the 2 power is 4. That's another nice one that I see. So we're just going to shift this over 4. So this is going to be right over here. You see how everything gets shifted over? Let's see another, I don't think I see another nice one. And if you remember how to get these points right here, this is 2 to the 1 power, so this should be just 2. I don't know why it doesn't look like it should be at 2. So it's 2. So that's going to be right here. So I'm just going to redraw this. So using those 3 points, I know it's going to be, again, my asymptote didn't change, so it's going to be looking like, running out of ink, like this. Okay. Asymptote is still the same. Because did we do any shifting of the any vertical shifting? No, we did not. So this stays exactly the same. So this is still the asymptote. So that's asymptote, but asymptote is just like a stop. Okay, so that's our new graph here. So this is the graph P of x, where we shifted it to the right 4. All right, so they're giving these as like the what is it, like the, something to copy. What is it called? I can't think of the word, but maybe you know the word. So same thing with, so for these ones right here, all you're doing is you're going to take all the points and you're multiplying the whole answer by 5, right? So that's, so this answer right here, so that's at 0, 1. So the answer, that would be the y normally, because if it didn't have that, it would, when we plug in 0 for x, our y is 1. Let's see if I could point out that, right? But then we're going to multiply that answer by 5. So it's just going to be up here at 5. And our every point, the y is going to be multiplied by 5, right? Because we're not multiplying the x by 5. We're multiplying whatever our answer is by 5. All right, I guess I'll just do that too. So that's, so we're not shifting anything. We're just dilating it. So everything gets like enlarged. Like we're doing one of these where we're zooming in, right? So this point goes up to here. We got, again, this is fx is 1, y is 2. So instead of it being 2, we're going to multiply that times 5. So that would be up here at 10, right? And so we can't even do these other ones right here, right? And so I do know that this should be 1/2. I don't know why it looks so weird. It should be at 1/2. But if this was 1/2, if this is 1/2, then multiplying that by 5, that was going to be 5/2, which is 2.5. That would be 2. So that's kind of, it's going to be this kind of very much more steep. Remember, it gets dilated. Steep line. Just like that. So we're taking all these points. So this gets, see if I can show you. So this gets translated up that way. Not translated, that's the wrong word. It gets dilated up that way. So everything gets multiplied by 5. So obviously if it's a smaller number, the difference is not going to be, the change is not going to be as much, right? So multiplying by 5 with a small number is not as bad as like multiplying a bigger number, like a 2 by 5, right? So that's what it's going to look like. And we're going to do one more on this page. That's going to be C. And if you notice right here, this is no longer in the exponent, so it is not related to the x. So we're going to be doing this part right here is going to be shifting it up or down. So which one is it? Yes, definitely. It is definitely down. If you said down, good job. If you said it too loud, well, you might want to look around. That's good. We're going to go down 3. So shift down 3. So instead of the asymptote being here at 0, y is equal to 0, we're going to shift that down 1, 2, 3. So all the points get shifted down 3. All right. So this point right here, that gets shifted down 1, 2, 3. And this point right here, shifted down 1, 2, 3. This point right here, shifted again down 1, 2, 3. All right. So I'm going to just draw this. It should look something like that. Okay, if you're getting it like a straight line, you did something wrong, because this is definitely supposed to be exponential because our x is in the exponent. All right, just like that. So we can do the same thing with the inverse. And what's the inverse? Did you say it? Yes. And so that's going to be, even with these logs right here, it's the same idea. Again, but remember our asymptote now is at x is equal to 0, because remember it's the inverse, so we flip the x and the y. So if you look at this, this is the -3. So what does that -3 tell us? Yeah, we're going to shift it which way? To the right. Oh, I did it with the wrong color because it was with the x. Sorry about that. That should be orange. All right, so we're going to shift everything to the right 3. 1, 2, 3. So our new asymptote is here at x is equal to 3. All right, so this whole graph just shifts over. All right, so I know that there's this intercept right here at 1, 0. So we're going to go 1, 2, 3 through to the right. See, 4 is the new 1. I knew it. And this is log base 10. So there's, remember that if there's nothing here is a base 10. There's not many other things because the next one is just not a good one. Just know that it can't get to 1 yet, because even if we do, let's see here, because this is going to be to the 10th power, 10 to the some power, so we're not even going to get there. So it's just going to be very, very close to the asymptote and just go like that. All right, and we'll talk more about how to graph these ones in the practice. All right, that's the shift. That's what the shift looks like. We'll do one more and then we'll get into the worksheet. Okey-dokes. All right, again, this tells us that this -3 is not with the x, which means we're shifting it up or down. And in this case, since it's -3, we're going to shift it down. So it's down 3. So we're going to go 1, 2, 3. So our asymptote did not change. Nothing to do with the asymptote. All right, because that's still going to be here, but we're just shifting all the points down. So this point right here at 1, 0 is going to be down over here. All right, just shifting it down 3. Yes, just shifting it down 3. I'm just going to draw it. So notice that this does not go up. It actually hits this point right here at 10 and then go 1, 2, 3. I'll tell you why in a bit, just not yet. Just know that we're trying to just shift everything down 3. That's all. So -3, that's outside of the x, that's going to be shifting down 3. And if it is the -3, that's with the x, like do you see how it's in the parentheses? I can only see it in here, but then you're going to be going left and right. Okay, dokes. All right, so you should all have this right here. And if you don't have it, then you should pause the video and ask the teacher if you can get this. All right, so if you notice right here, you have 2 to the x. So we'll just do a basic one, no shifting, no transformations, just straight 2 to the x, right? How do you do that? Actually, let me use just a regular, we don't have a regular pencil. I'll just use blue. All right, so normally we've been using tables, so that's what we're going to do. So we know that our asymptote is going to be at 0, at y is equal to 0, because if we keep on multiplying by 2, you're never going to get to 0. And if we do the reciprocal of this, when we go in the negative exponents, you're going to be multiplying by 1/2. And again, you're never going to get to 0. So there we go. So that's our HA. All right, so now we're going to just plug in some numbers for x. Remember, like I said, we're going to just plug in some negative numbers, 0, and some positive numbers. I don't like to go very large, although we could even get to a 3 just because it's just a base 2 instead of like a base 3. So let's go. If you plug in -2, 2 to the -2 power, so let me just write the work here. So f of -2 is equal to, what is it going to be? 2 to the -2 power. I have to kind of write it below that. And remember what this negative exponent tells us. It just means that this is supposed to go on the denominator of the fraction. So this is just going to be 1/2 squared, or what we know to be 1/4. So that's just 1/4. So when x is -2, it's going to be a quarter of the way up. So it's like right about there. It's not halfway. It's like half of a half. All right, and then same thing with the -1. So that's going to be 2 to the -1 power, which is just 1/2. Or 1/2, or just 1/2 to the 1 power, which is again just 1/2. So that's going to be a half right there at -1. And then 2 to the 0 power, I'm just going to go 2 to the 0 power, which is just 1. Anything to the 0 power is 1. 2 to the 1 power, that's going to be 2. 2 to the 1 power is 2. And 2 to the 2 power is 4. Right there. So technically, I mean, I know how I'm going to, if I want to be more accurate, I know 2 to the 3 power. So that's going to be 8. And 2 to the 4 power is 16. You know, just you can't do 2 to the 5 power because that's 32. And this only goes up to 20. So that's not possible. And we know here it's just going to keep on getting smaller and smaller. So we're just going to draw that line to make sure that we are not, again, going away from this line. It's not curving up like this. It's just going straight, getting closer and closer to the asymptote. If I could do this, a little bit wobbly. But there we go. There's our exponential, 2 to the x power. All right? Notice it kept on doubling. It was 2 and then 4 and then 8 and then 16. That's what this is. Like 2 to the x power is doubling, right? So same thing here. Let's take a look at number 4 since that's very similar to what we have. Now, what if we don't see, do you see how we don't have any like 2 to the x power already drawn on here? What happens when you don't have that, right? Because you're not always going to have that as a guide. So we're going to do some shifting here. So if you remember this plus 2 right here, that told us we're going to go the normally we would say to the right 2, but remember it's opposite of what we see because it was originally supposed to be a minus. So that we're going to shift left 2. So all of our points are going to move to the left, which means our y-axis is now moving to the left 2. Okay, so this is new y-axis. All right, I like doing it this way just because it's less calculations to do. You can, like pick a number for x and then, pick plug and chug kind of thing. But I feel like this is just easier if you know how to do transformations. That's just a long way to do it. So the minus 1, remember, it tells us we're going to go down 1. So our asymptote is going to go down 1. We're shifting everything down. Okay, so this is our asymptote, which is not y equals 0 anymore. It's y equals -1 because we shifted it down. Okay. And then from here, remember, we're just now going to be graphing just this part right here because we've already done the shifting, so we're just looking at this part right here. We've done that before, right? So 2, and then this is, I'll just say 2 to the x power, just so that we don't get confused. If I put f of x here, it's not talking about this f of x because this f of x has all these transformations going on, right? So I'll just be like 2 to the x power. And we've already done this one, remember? So remember we did -2, -1, 0, 1, 2. I'm not going to show the work again because it's right here, right? So I'm going to go 1/4, 1/2. So 2 to the -2 power is 1/4. 2 to the -1 power is 1/2. 2 to the 0 power is 1. 2 to the 1 power is 2. 2 to the 2 power is 4. We're going to use this and plot it on our new x and y axis. Okay, ignore these numbers, okay, because they are incorrect right now. All right, so just for while we're graphing. So if x is -2, so we're going to go -2, and then we're going to go 1/4. So we're going to just go up 1/4. If x is -1, we're going to go up 1/2. Okay, again, do not get confused with the previous x and y axis. And 0, 1, so we're going to go 0, 1. And then 1, 2, so 1, 2. And then 2, 4, 2, 4 right there. All right. Again, if you want to be a little bit more, if you want to be extra, 2 to the 3rd power is 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then it's going to be 16. So that's going to be 16. So it's 1 below the original 16, right? Because remember, we shifted everything down 1 because of, this -1 right there. All right, and so now we're going to get this is our new graph. All right, so this is how transformations work. It makes life a lot easier because you don't have to think about, well, okay, what do I make x? And then just because you have, notice right here, like if we use, we need to use a -2, 1. Okay, so when I ask you what is f of 2, you just go to the 2 and be like, oh, it's 15, right? So 215 if we're looking at the whole thing, right? But just when you're graphing, that's when we use these ones right here, these values, okay? And then when we take a look at the whole graph as a whole, and we want to see what the values are, we can look at now like the actual numbers that we said we were. And if I ask you what's the x-intercept, you will be like, oh, at -2, 0. What's the y-intercept? At 0, 3. Right? So just so that you know, so let me use different colors here because those were already taken. So again, x-intercept is now at -2, 0. Because remember before we did not have an x-intercept, right? Because the horizontal asymptote was on the x-axis, but remember since it got shifted down, Now we can have an x-intercept. And then the y-intercept is going to be at 0, 3. Horizontal asymptote is at y equals to -1. Remember, that's an equation, right? And I'm doing these in these are dotted lines. The new x and y axes are dotted because they're just guidelines. They're not actually like anything. So again, press pause, try it out yourself. You got to give your brain a chance. And then if you're like, I really still don't get it, I need to listen some more, you can repeat that again, or you can watch, we can just solve some more together, okay? So we're going to go to number 3 right over here. And here it says we're going to go -1, so that means we're going to go to the right one, right? It's opposite of what we see. So we're shifting everything to the right. And then this right here, we're shifting things down to. All right, if you notice right here, this program conveniently gives it to you so that it's like already adjusted for you. On the test, it's not going to be like that. In real life, it's not like that. We don't know. So you got to remember to remember why we're shifting it down to, because of this guy right there. All right, and then so this is to the 4th power. Okay, that's easier to calculate than all these other things. So I'm going to be like, well, this is my x and this is my 4 to the x. Right, my f's, I'm just going to go -2, -1, 0, 1, and 2. Right, and if -2, so that's going to be 4 to the -2, which is just 1 over 4 squared, which is 16. So it's 1/16, barely above. So that's going to be -2. Remember my new -2. So 2 to the left from the new x and y axis, and then up 1/16. So it's like barely above. It's like, you see, it's like barely above. And then 4 to the -1 is going to be 1 over 4. 4 to the 0, what's 4 to the 0? 1. 4 to the 1 is 4. And 4 to the 2 is 16. Okay? If you need a little visual there for those people who need, like to see it. Okay? So that's a lot easier to calculate than trying to, okay, x minus 1 and then do the exponent of that and then minus, it's just a lot. Okay, so and then we're just going to graph it. So -1, we got 1/4, so it's like a quarter of the way up. And then 0, 1, so 0, 1. Then 2/16, so 2. And then we're going to go all the way up here to 16. 1, 2, 3, 4, right? Count it all up. That's going to be 16. And so here, do you see it's a little bit more steep? Oh, shoot. Oh, no. Oh, that's not good. I went too fast. Okay, that was a little tough. All right, so that's what that graph is going to look like. It's super duper steep because it's at 4. So if we're quadrupling, it's a lot. It went from 4 to 16, and what's after that? 16 times 4, right? 64. Like, you see, it's huge. It's like leaping and bounding. All right, so that's what that looks like. Let's see, take a look here. Oh, so for those guys who just wanted to see it, let me just show you. So if you want to do it the long way, you're like, Miss Lee, this transformations, I'm not really comfortable with that. Is there another way, right? So if you wanted to, you could be like, well, f of 1, right? Let's try f of 1. And so you plug in 1. So that'd be 4 to the 1 minus 1 minus 2. So you're literally just plugging in 1 for x, copying everything else down. And then so 1 minus 1 is 0 minus 2. Right, 4 to the 0, what is that? 1 minus 2, which is -1. Do you see how much more work you got to do? And then so we got 1, if x is 1, y is -1. So if you go x is 1, y is negative. Look, it's that point right there. Right? That's the point that we were saying. And so, yeah, so what this does, transformation does, is really helps you take care of all of those, because we're already taking care of this -1 and the -2, so we don't have to do it again, right? So we just have to look at the 4 to the x power, which makes calculations a lot easier, okay? And you're a lot less likely to make mistakes, because anywhere on here you could be making mistakes. Even if you put it in the calculator, you could still make mistakes. I've seen people do it. So the less mistakes you can possibly get, the better. All right, again, pause, Try it yourself, try number 2 yourself, and then, you can press play. All right, so this is 1/2, which is pretty much this, but backwards, right? Because it's a decay instead of a growth. All right, and so we're going to take care of these transformations first. So this -1 tells us we're going to shift things 1 to the right, opposite of what we see. And then we got this +2, and that's shifting everything up 2. So this is our new x and y axis, and our HA, our new horizontal asymptote, is y is equal to 2. All right, and think about how that would change the domain or range. Okay, it doesn't change the domain, but it does change the range. Okay, and then let's just do some calculations. So again, we're going to have our table. X, -2, -1, 0, 1, 2, and this is going to be 1/2 to the x power. Okay. In this case, we want to include the parentheses because we're saying that this x is not just for the 1, it's not just for the 1, it's for the 2 as well, right? So 1/2 to the -2 power, right? So this 1 is going to go to the bottom and this 2 is going to go to the top. So it's just going to be 2 to the 2 power, right? Because over 1, it's just the same thing. So 2 to the 2 power, which is 4. And then 1/2 to the -1 power. So that means this -1, so this 1 goes to the bottom, and this 2, since it's already on the bottom, it goes to the top, 2 to the 1, which is just 2. And then 1/2 to the 0 power is just going to be 1. 1/2 to the 1 power is 1/2, right? That doesn't change. And 1/2 to the 2 power, 1 squared is 1. 2 squared is 4. All right, so we have 1, 1/2, and 1/4. All right, so let's try to take a look there. So remember our new 0, 0 is right here. And we're going to go 2 to the left and then up 4. 1, 2, 3, 4. And then -1, up 2, 1, 2. And then 0, 1. And then 1, 1/2. And then, so the hardest thing about this one is not looking at these numbers. It's really easy to look at those numbers and be like, oh, this is what it is. You can do that. Okay, so just make sure you're counting it out. Okay, if you want to logically reason it out and be like, oh, since it's supposed to be up 4, but then we moved up 2, so it should be at 6. You can do that too. Good luck. Just because I like to be a little more accurate. If it was -3, that means this is, going up to 2. What is it? 4 times 2, which is 8. So this is going to be 4, 5, 6, 7, 8. And then 16. There. I just like to make it look nice. Why not, right? There again, we're just going to continue. It's going to look almost parallel to the asymptote, but it's not parallel. It's supposed to be getting closer to the horizontal asymptote. All right, so that's what that's going to look like, just like that, with all the transformations there. Okie dokes. All right, so now how do you do that with the log, right? Very carefully. Same thing, just one added step. Okay, so if we take a look right here again, this -1 tells us we're going to shift everything to the right one. And then this one right here, the -4, it's not a part of the x, so then we're going to go down 4. All right, so what we're going to do again is we're going to look at just this part right here. And since logs are a little weird, I like to change them into exponentials first. Okay, so remember this is just y is equal to log base 6 of x. Remember how to change this to exponentials? Our base is 6. And what is our exponent? Whatever the log is equal to, right? So that's the y. So 6 to the y is equal to x. Okay, we've done a lot of those before. You might want to look at your previous work to see how to do that. So now we're just going to make our xy. So here's our xy. So now this is a little weird. Normally we pick our x's, but in this case, it would just be easier to pick your y because y looks like it's the independent one. So y would be easy to say to remember. Oh shoot, there we go. Oh dear. Okay, so we're gonna go y to the. We got to do some negatives, but not. I'm not gonna go too negative because that's gonna be really really small. So -1, 0, 1, and I don't think we can even do a 2 because, well, I'll show you why. Right, so 6 to the -1, what does that equal to? 1 over 6. So that's what x is going to be because that's what x is equal to. And then 6 to the 0, that's going to be 1. So that's what x is equal to. And then we got 1, so 6 to the 1 is just 6. So there's that. And see, this is why we can't use 2, because what's 6 to the 2? 36. Yeah, we can't graph 36. This goes to 8, right? Not happening. So that's where we're going to graph. So this is going to be 1, 6, and then so x is, so from the new, we transformed it, right? So go 1, 6 to the right. So that's like barely to the right. And then go down -1. It's like right about there. Okay, it's probably made 2 to the right, too much to the right. And so if x is 1, y is 0. So x is 1, y is 0. This is the hardest part, I think, because people get confused. Because most people want to do the 1 for the x and then 6 for the y. Don't do that because you're doing exponentials at that point. And then x is 6, so 1, 2, 3, 4, 5, 6, and then up 1. All right, and we know that it's going to be approaching the asymptote. There we go. And there it is. There's your transformed one. It talks about domain and range. So domain, how far left does it go? Up to 1. Doesn't get to 1, gets close to 1, but it doesn't get to 1. But that's our domain. Our range is going to be, well, it goes all the way down. It is slightly tilted up, which means it's going to do all of that, right? It's not a horizontal asymptote anymore. It's going to be our vertical asymptote, which is going to be x is equal to 1. Think about where you see that here, right? Where is that x equal to 1, right? Right? Remember our transformations? They are all related. All right, we'll do a couple more. Actually, we'll just do the rest, and then you can pause and stop and rewatch or whatever as much as you want, right? But this is the power transformations. -1, so we're going to go to the right one again. I didn't do a lot of different numbers. I should have just done different numbers. What was I thinking? Oh well. -1, and then we're going to go -2, so it's 2 down. So in this case, our base is 5, which is different. So I'm looking at just this part right here. So I'm just going to convert that to exponential. So y is equal to log base 5 of x. So that's going to be 5 to the y power is equal to x. Remember, our argument equals to the argument. And no need to argue about that. Come on. All right, again, we're going to choose our y's. I'm not going to go very large on this one, just -1, 0, and 1. Remember, because if it's to the second power, 5 to the second power is 25. Can't graph that. No point. Okay, so then 5 to the -1 is going to be 1 over 5. And if y is equal to 0, that's going to be 5 to the 0, which is just 1. And 5 to the 1 power is 5. All right, so I'm going to go again, my new x and y axis. So I'm going to go 1/5, so a little bit to the right, and then 1 down. In general, that's how logs work. And then we've got 1, 0, perfect, and then we've got 5, 1. So 1, 2, 3, 4, 5, and up. And there we go. Logs. Done. Happy days. All right, so that's how that goes. And then we're going to try this one right here. Oh, should we talk about domain and range? Again, domain. We shifted everything to the right one, so it's going to be from 1 to infinity. Range is going to be all of them. And then the vertical asymptote, again, is still x is equal to 1. because we did the same transformation. We still did the -1 here, so that's going to remain the same. All right, for number 7, same thing. So now we have +1, which means we're, instead of going right 1, we're going to go left 1. So this is a little different. All right, and then we are going to go +3 and go 1, 2, 3 up. So shifting everything up. All right. And now, okay, do you guys remember this? I talked about this before in passing, perhaps, but ln, what does ln mean? So ln of x is equal to log, it's just a log, base e. Do you remember the e that we had calculated out? Remember 2.7182845904523? That's the number, and then it goes on forever. Yeah. So whenever you see a log base e, that's just the natural log. So this is what we call the natural log. Naturally. All right. So that's what we have here. So if it makes you feel better, if you're like log y is equal to log base e of x, we're just gonna change that. So it's gonna be e to the y power is equal to x. And you may be wondering like, oh, what? Same thing, except we need a calculator at this point. So again, we have our x and here's our y. So x is going to be, so remember e is like 2 point something, right? 2.7. So we're not going to go that, well, 2 to the third power is 8. So yeah, we'll see. But we can just go -2, -1, 0, 1, 2. Let's just try it out, right? And then we have our calculator. So if you want to go get your calculator, you might just put it this way. All right, so we're going to go, oh, did you see what I did wrong? Did you see that? Did you be like, Miss Lee? Do you see what you did wrong? Put it on the wrong side. Because that's supposed to be for our y, not for our x. That's why this is erasable. Happy days. It was like it never happened. All right, so we're going to go e to the -2. So remember our e is going to be, do you see right here? There's a ln, right? Log, natural log. And so we're going to go second that to access the blue. So see how the second button is blue? Then that will access the blue stuff. So you should get E with a little exponent thingy there. We'll go -2. Please make sure you're using this as your negative and not the minus. Okay, it is treated differently here on the calculator. Oh look, a 0.14. Okay, we're just gonna go 0.14. All right, we're gonna do the same thing. So second natural log, and then we're gonna get -1. So it's going to be 0.37. Please make sure you're rounding it correctly. Since the next to the 6, the 7 is 5 or greater, that means this 36 is closer to 37 than it is to 36. All right? And then e to the 0. Ooh, I know e to the 0. What's e to the 0? Anything to 0 is 1. You don't believe me? See? Told you. And then e to the 1, we should know that. E to the 1 is just 2.718, so 2.72. Remember, it rounds. And then e to the 2. Okay, don't know that one. E to the 2 is going to be 7.39. All right, so let's graph this. So x is 0.14, so that's like barely to the right. And we're going to go down to 1, 2, just like that. 3.7, or 0.37, and then 0.37, so a little bit, not half yet, and then to the -1. And then we got 1, 0. Please remember you're using your new x and y axis. And then x is 2.7, so here's 1, 2.7, so like right about there, and 1 up. And then 7.39, so 1, 2, 3, 4, 5, 6, 7, and 3, 9, so about there. And then I'm going to go up to, there we go. and it is looking the way we expect it to look, just like that. These are what logs look like. All right. So if it is a natural log like that, feel free to use the calculator just like how we did. Just put in, just in case, e to the negative 2, right? And what happened here? We'll talk about that, but before we get to that, let's do the transformations. So again, this is minus 1. I told you I should have looked at the numbers a little bit carefully, more carefully. All right, and then we're going to be going up one right here. And then, so remember we talked about where if there's nothing there, what is the number there? Yep, I hope you said it. Log is base 10 of x. It's normally base 10. So anytime you see a log of x, that's the same thing as log base 10 of x. So this is what we call the common log. Okay, so there we go. And then now we're going to just change this to exponentials. So our base is 10 to the y is equal to x. Not terrible. I'm not going to go very far on this one, just because this base is 10. We're not, if y is 2, it's already 100, so we're not getting very far. So negative 1, 0, and 1 is what I'll do, and then we'll go negative 1. So 10 to the negative 1 is just 1/10. 10 to the 0 is 1, and 10 to the 1 is, I did it again, didn't I? Yeah, I did. I need to stop doing that. Sorry. I need to just flip-flop these, because my y is the exponent. I'm so sorry. I hope you were like, Miss Lee, what are you doing? I thought we couldn't do that. Like, I was about to be so confused. So negative 1, 0, 1. Now that would be 1/10. There we go. And then 10 to the 0 is 1, and then 10 to the 1 is 10. Whew. So again, our new x and y axis, 1/10, so barely to the right, and negative 1. And then 1, 0, and then 10, 1. Oh, I can't even do that. So we know I'm, so it's just, there we go. I made sure I wasn't going to get to that until, because that is not supposed to intersect until like 10, 1 over here. All right, there we go. That's what it is. Done. Oh, domain and range. Oh, should we do the domain and range for this guy over here? So domain and range. So x can be up to negative 1, right? Or it can't be negative 1, but, right after that. And then range, still going up and down, so it's still going to be negative infinity to positive infinity. It can be anything. And then our, what is the thing called? Vertical asymptote. The only asymptote we have here is going to be x is equal to negative 1. Same thing for this one. Domain is from 1 on. And then range is going to be from negative infinity to positive infinity. It's all the things, right? And then our vertical asymptote is going to be right here at x equals to 1. All right, so please practice that, and yeah, repeat any parts if you need. If you need to work on your, well, have a good one.